Good morning everyone. Today we will do the solutions of theory of structure first. Let us see what question tells us. So we need to calculate the horizontal deflection at point E of this falling frame. Take EI as constant throughout the member. So you have been asked that with the application of this amount of load, this frame will deflect, right? Application of load, this upright member may deflect like this. So you need to determine the horizontal deflection at point E of this member. So this is the asked thing. So what can you do for solving this type of problem? So for this, I will be using the virtual work method or unit load method for this solution. So for that, let us see how can we do that. So this is A point B, C, D, E, F, and this point B, F. At first, you need to make the real system and you need to apply the load at point A so as to determine the virtual system. So let us try to make a real system of this given frame, and we will be applying the unit load at the said position, that is E. So it has said the horizontal deflection, so we need to apply the horizontal force at this given point E, right? So at first you need to balance this frame and determine the moment at the individual sections. Yes, so for this let us try to do the solutions. Okay, so first calculations of the support reaction. Let I make this is the hinge support. There are two unknowns. Let I say these unknowns be in y direction RAY, in x direction it will be RAX, and this be RFY, right? So if you do calculations, if you do summation of moment about point A is equals to 0, if we take clockwise as positive, what will happen here is that RFY is giving you anti-clockwise moment at point A, that is RFY into distance. This is 4 meter, this is 4 meter, and here is 20 kilonewton, that is giving you clockwise at point A. 20 kilonewton into distance is 2 meter, right? This is clockwise. Here it is uniformly distributed load of 10 kilonewton per meter. It is giving clockwise moment about point A, so you have to write plus, so it is 10 into distance is 4. Its line of point of application is the centroid point of this geometry, that is 4 by 2 is 2 is equals to 0. If you solve this, 4 RFY is equals to 40 plus this is what, 80 into 40 into 2, 80, right? So RFY is nothing but, it is nothing but 30 kilonewton. That is in the upward direction. So RFY is 30 kilonewton in the upward direction. So likewise, if you do summation of force in y direction is equals to 0, then this is what, 10 into 4, 40, this is 30, right? 40 is downward, 30 is upward. So you can directly write the value of RAY as 10 kilonewton, right? So RFY is the 30 kilonewton. Okay, so this is the simple calculations you can do. Now again, you have to determine RAX, it is because 20 is acting toward the rightward direction, so RAX must be in the leftward direction. Its value must be 20 kilonewton. Okay, since you are doing the M system, this is the real system, so now you need to balance this system and make a figure. To this, you have to make a balance system, right? So what does a balance system looks like? You can make a figure like that. So I will try to make a balancing of this frame. So let this be A, let this be point B, let this is your point C. There is a C and D. This is CD span having a UDL of, it has 10 kilonewton per meter. Okay, likewise there is DEF section. So let this be your D, this be your E, this be your F section. Okay, so now what you have to write is the external forces and the reactions that you got from this system. So you can say that at A there is 10 kilonewton acting upward, and at F there is 30 kilonewton support reaction acting again upward, right? So this is nothing but 30 kilonewton. Other than that, what you can write is, look, so this is 10 kilonewton, and here it is, we have 20 kilonewton horizontal force. Okay, so now your task is to balance this system at first. So make a system in such a way that it can be balanced, right? Okay, so I am making this a real system, right? So I need to balance this system. Let us try to balance each and every member. So 10 kilonewton acting upward. To balance this, let us say we have like the 10 kilonewton axial load to balance this, right? Okay, again we have here 20 kilonewton load. This is the reaction load, reaction force that developed at the hinge support, right? So 20 is balanced by 20, shear is balanced, axial is balanced. Now you have to determine what the moment that develops at point C or joint C of this member. So let us say 20 kilonewton into 4 is what? 80 minus 20 into 2, that is 40. So it appears to have a clockwise moment of what? 40 kilonewton, since 20 into 4, 80 minus 20 into 2, that is 40. So that is occurring at clockwise direction. So to balance this, you need to apply the moment in the anti-clockwise sense, that is 40 kilonewton meter. Okay, so this is the simple things that you can write. So this is 40 kilonewton. So to balance this is the added thing. So you need to make this system, since you have written this, so to balance 40 you have to write 40 kilonewton in clockwise sense. Okay, yes. Now this is the added thing. To balance 10 you have to make 10 kilonewton like this. Okay, now say what you can say is that, so this shear force in this member have been balanced, 10 is this axial force is balanced, and moment is balanced. Now there has been transfer at point C or joint C. So joint C receive 40 kilonewton meter from this section, 10 kilonewton is balanced like this. Now at joint D, what will be the shear force, what will be the axial force, and what will be the moment? You have to calculate like this. Since this is 4 meter, so now let us make a balance of the shear force. So 10, here is 10 into 4, 40. 40 downward, 10 upward. So to balance this, you have to write 30 kilonewton in the upward sense. Yes, so now you have to balance the moment as well. There is no any axial force here. So moment is 40, right? 40 clockwise. So here is 40 clockwise. Again 10 into this distance is what? This distance is 10 into 4, 40. Okay. So 40 is clockwise. 10 into 4, 40 clockwise, minus 10 into distance is 4 into distance is, the point of application of the force is 2, right? So 40 plus 40, 80 minus 80, 0. So at point D there is no any bending moment, right? At point D there is no any bending moment, so this is 0, it has been balanced. So since it is 0, in at point D there is no any bending moment as well, right? So now 30, so this is balanced, balance this section. So 30 is upward, so for that you need to balance the 30 kilonewton like this. Okay, so there is no any shear force, no any bending moment in this section. So this is the real system. Real system I'll be writing is as capital M system, right? Okay, so this is your capital M system. In the same manner, what you need to do is you need to make a virtual system as well. Now Since you have been asked to determine the horizontal deflection at point E, at point D, so you have to apply the horizontal force or unit load at point E. So in the horizontal direction itself, right? So at point E, maybe like this unit load or maybe like this unit load based upon your assumption, right? No, and there is no any problem in the directions what you assume at point E, right? It must be horizontal unit load at point E, since we are solving this by the unit load or the virtual load system. Okay, so I will make this virtual load system or unit load system like this. Okay, so this is your, let us suppose this is your system, this is your point A, B, C, this is D, let this be your E, and this is F, right? So I apply a unit load at point E like this. So this is your system, and you have to remember that in this case you have to remove all the external loads and you have to only apply the unit load that have been given in the question, right? Since you have been asked to determine the horizontal deflection at point E, so the force must be horizontal and it can be along rightward direction or in maybe in the leftward direction, right? Okay, so you have to write the support as well, and based on that you need to calculate the support reactions of the unit load system or virtual load system. Okay, so you need to calculate this thing. So this is 2 meter, 2 meter, 4 meter, and this is 2 meter, and again this is 2 meter. Let's suppose this be RAY. Let's suppose this is your RAX. Let us suppose this be your RFY. So if you do the summation of moment, you need to calculate these reaction force at first. Because of that, you can use the bending moment calculations on the individual section. So I write the summation of moment about point A is equals to 0. Let I suppose this clockwise as positive. Then what will happen is here RFY is giving you anti-clockwise. It is minus into distance 4 meter, and it is giving 1 is giving you what? Clockwise. So it is plus 1 into distance 2 is equals to 0, right? So what you can say is that 4 RFY is equals to 2, and if you solve that, RFY is 1 by 2 in your assumed direction, right? So RFY is 1 by 2. So since it is 1 by 2, to have this balanced system, RAY must be in the downward direction, right? So if you know this, then you can determine the reactions of this system. 1 by 2 kilonewton, RFY is half kilonewton acting in the upward direction, and RAY is again what? Half kilonewton acting in the downward direction, right? And if you use the summation of force in x direction, it can be easily said that the value of the reaction force in the horizontal direction at point A will be nothing but 1 kilonewton, like this. Yes, so this is the calculations of the support reactions for the virtual system. Now what you have to do is you need to use this thing, right, and balance this system at first. Okay, so let us try to balance this system of the virtual system, right? So balancing this frame. So let us see this. I will try to draw in a smaller way. Let this be another section. Okay, let's try to give the naming of it. A, this is B, this is C, C, D, this is D, this is E, and this is F. So this is your system. Okay, so what the reaction force you got? Acting downward at point F, there is half kilonewton acting upward, and at point A you got 1 kilonewton acting upward, right? So the distance is 2 meter, 2 meter, this is 4 meter, and this is 2 meter, again this is 2 meter. Okay, it's your task is to balance this system. Okay, now let us see how you can balance this system. At point E there is again what, 1 kilonewton. This is the horizontal reaction force at point what, E, that you have assumed. Because of this 1 kilonewton the reaction force come like this, 1/2 kilonewton acting downward. Okay, so to balance this you have to apply 1/2 kilonewton upward force. These have been added, so to compensate it there should be 1/2 kilonewton downward force. So 1 kilonewton is here, right? So to balance this 1 kilonewton force should act like this, and to balance this 1 kilonewton should act like this, right? So for the balancing of this 1 kilonewton force should act like this, and this is the added portion. To balance this 1 kilonewton force act like this. In the same manner, half kilonewton is here. To balance this, what will happen here? You need to add 1/2 kilonewton upward load, and to balance this you have to apply half kilonewton downward force. Yes, so this is the thing that you have to do. Now along with that, you balance the axial force and shear force. You need to balance the moment as well. So let us try to make what will the moment that will occur at point C. So now see, at point C there is the distance of 4. So this will not give you any moment, bending moment. So 1 into distance 4, that is giving 4 kilonewton meter of the clockwise moment. So to balance this you need to apply 4 kilonewton meter anti-clockwise moment at the joint C. So this will be 4 kilonewton meter. Okay, I make this moment with the another color so you can visualize it. So this is 4 kilonewton meter of anti-clockwise. So to balance this there is the clockwise moment of 4 kilonewton meter. Yes, now say, so there is 4 kilonewton meter clockwise. So what will be the moment about D? That will be 4 clockwise minus 1/2. So what you can say is 4 is clockwise minus 1/2 into distance is 4. So that will be 2 kilonewton of clockwise moment. So to balance this you need to apply 2 kilonewton meter anti-clockwise moment. This will be 2. Now since it is the 2, that joint transfer the moment at joint D. So 2 anti-clockwise, so at point D what it will be the moment occurring at as D as 2 kilonewton meter clockwise moment. Okay, so let us see what will happen here. So at point D it is 2 kilonewton meter, right? So it is 2. Now let us check at point F there is the moment of 0. There should be the bend moment 0, right? So what will happen here? 2 into this, look, 1 into this distance, total 4, that is 4. 1 into 4, that is anti-clockwise, plus 2 is clockwise, again plus 1 into 2 is clockwise, right? So that is 0. So whatever you write is correct and it is balanced. So this system have been balanced. You need not to worry about this, right? So this is what you can say is the virtual system, unit load system or the virtual system, right? I assume this system as M system, small m system. Okay, so after doing that, now your task is very easy. You have to write the formula to calculate the horizontal deflection at this point E. So this is M system. So this is small m system, right? Now the formula is very easy, that the deflection at this point E will be in this system the summation of the moment of the real system and the moment of the virtual system divided by EI. So for the integration, let us try to write the moment in the equation form so that we can generalize it and make the equation, right? This is a portion. Okay, now what is the origin? You have to write origin, and you can write what is the limit. Okay, so since ei, the flexural rigidity is constant here, so ei value is 1. I am not making the column of ei here. If the rigidity have been asked to be different one, so you need to make a column of flexural rigidity as well. Now the real system value, that is m, okay, and the virtual system of unit system as small m. So I make this thing here. Okay, so you need to was this system and this system to write this table. Okay, now let us see what the portion. Now you have the section A, B, B, C, C, D, D, E, and E, F. So there are 2, 3, 4, 5 sections, and you need to write the equations of that section since you can use the integration then. Okay, so here portion, let us make portion AB here. So the portion AB, if I cut the section like this, then okay, then the origin I am taking as A, and limit the AB section, the limit will goes from x is equals to 0 to x is equals to 2 meter, right? If you make this section, if you cut this section AB, and if you take x from origin A, then x will vary from x is equals to 0 to x is equals to 2. So limit will be 0 to 2. You get my point? So what is the M system? So M system is, so this system, so what is the bending moment about this section x in this case of this system? So this is nothing but 20 into x. If you take this x distance, so this will be 20 into x, it is clockwise, right? So you can write 20 times x. Clockwise movement from left to right, clockwise is positive, or you can say that the sagging moment is positive and hogging moment is negative. So hogging moment positive and hogging moment is negative, right? So 20 into x, so that's 20, right? If you take like this, so you need to be careful in this table that if you take the origin of this system as A, and if you take the x from like this, in the virtual system or the unit load system, you need to take the same thing, same section from that origin as well. So you need to take the same origin and the similar type of limit and similar type of assumptions as you have assumed in the real system as well. So for that, so you take the origin at A, the limit A to B varies from 0 to 2, and the system, the moment about this section will be nothing but it is 1 into x, that is x, right? So x is the distance that you have assumed from the considered origin. That's the thing. Now, so AB portion have been written. Now write BC portion. Okay, you can take the origin as this or this. So I will try to take the origin as this first, A. Okay, it depends upon your way of calculating, right? I'm taking the origin as A, the section is BC, right? So if you take the origin at A, it means that the origin as A, so that your x will be going from this origin, right? From this, right? Your x have been assumed like this. Okay, now you get my point. Your x will be like this, but your considered section is this, so the limit will range from limit, what is the limit here? You consider this, so x will be, the limit will be 2, the limit will go up to 4, right? It's a BC section, so x will be going from 2 to x will be going from up to 4, right? So what you can write is its limit 2 to 4. Now the moment about this section will come out to be 20 into x is 20x, clockwise movement. Okay, 20 into this x clockwise, and this is what? Anti-clockwise, negative 20. What distance is this? This is x minus 2. X minus 2. Okay, so if you solve this, 20x minus 20x plus 40, 20x gone, what you can write is only 40 kilonewton meter. Okay, so there is only 40 kilonewton meter of movement about this real system. In the same manner, you have to write the moment of this virtual system by this consideration. What the consideration is, this is the origin at A. Your x is assumed at this BC section from A. The limit of x will be going from x is equals to 2 to x is equals to 4. And in this system, what will be the bending moment? Since it is assumed at here A, so it will be what? 1 into x. This x is here. Let us suppose that 1 into x is clockwise positive, right? So again it will be only x. I assume this thing as the origin like this. You can also make the origin as not A, you can make a B. So if you have assumed the origin as another thing like B, there will be that change here, right? If you just make the origin as B, if you make the origin as B, then the limit origin as B, then if you have to assume x from here, right, from B, so then x will be going from x is equals to 0 to x is equals to 2, right? In this case, what will be the moment? In this case, if you take like this, what will be the value of the moment? X will be not from here. In this case, x will be from here. So the value of moment is 20. This is 2 plus x, x plus 2, clockwise minus 20, what? It is x. So 20 is gone. 20x is gone, that is again 40. The value of the moment of this real system will be nothing but 40, right? If you assume the v as origin, so limit will be changed, it will be going to 0 to 2, right? In a similar manner, you have to assume, if you assume like this, for the m system, you have to go from B, from this origin B, right? So what will be the value of the moment in this case? The moment this, so that will be x, this is 1. What is the distance? It is this x distance, so it is 2 plus x or x plus 2, right? So it will be changed like this. That will be 1 times x plus 2, right? So it will be changed like this. But it is not necessary you need to calculate both things. You can do like this or like this. I have just given the what it is, maybe the alternative thing, right? Now, in the same manner, you have to take the section CD. Now, for the section CD, if I take C as the origin, what will be the limit here? It will go from x is equals to 0 to x is equals to 4. What will be the value of bending moment in this real system? So this will be 40 kilonewton, already clockwise moment. So 40. Again 10 is given at x distance, 10 into x clockwise, 10 into x clockwise. This 10 is giving you anti-clockwise. This 10 kilonewton meter is giving anti-clockwise. That will be minus 10 into x by 2. So that will be 5x square. That will be nothing but 5x square. What is the value of m system? So there is, you have to determine at this section x, what is the value of moment. So there is 4 kilonewton meter clockwise, and there is 1 by 2 downward direction, it is giving you anti-clockwise. So at x distance, it will be x by 2. So that will be 4 minus x by 2. If any case you do not like the origin of C, if you want to make the origin as D, you can write that as well. But while doing calculations, you can use either of that, right? So if I do the origin as D, what will happen? Let us see. Okay, if I do the origin as D, let us make this as origin. The limit will be 0 to 4 itself. What will be the moment about this section x if you take from D, right? So that will be 30 into, that will be nothing but 30 into x is giving you anti-clockwise. From right to left, anti-clockwise is positive. So because of that, so 30x I write it. And 10 is giving you clockwise, so that will be negative of 10 into x by 2 into x by 2. So that will be directly 5x square. So if you take D as origin, the limit will be changed like this, and the value of the real system will be changed like this. Okay. In a similar manner, if you take the origin as D of this virtual system, what the value of moment will occur at this section x if you take D as the origin? So then look, 2 is anti-clockwise, so 2 is positive, 1 by 2 is upward, so it is giving again anti-clockwise, right? So it will be 2 plus x by 2. Now, so it is over DE and EF. So DE, let us try to make a DE section, and let us try to write the origin. I assume it as D. Let us suppose that this origin as D, the limit will go from 0 to 2, right? And what the value of moment in this case will be, right? So 30, there is no any shear force, the only axial force is there, so 30 cannot give any moment, there is no any moment, so M system will be 0, right? In the similar manner, small m system or virtual system, look the system what will be there. So look, 1 by 2 is not giving you anything, 20, so this is 2 kilonewton clockwise. So at point, if you consider D as origin, again you got 2 as clockwise and 1 is giving you anti-clockwise, right? So it will be minus 1 into x, that will be x. Now EF, now one section is remaining, EF, and for EF I can assume E or F section as origin, since look, the origin is considered based on how fast the calculations you can make, right? Okay, how fast the calculation you can make whatever origin you like. Assume the F as origin. So if F has origin, the x will be from F go with that section EF. Then the limit will be 0 to 2. Right? Limit will be 0 to 2. The value of M, capital M or real moment system will be nothing but, so there is no any shear force, 0, and will be again 0. Right? Since there no any force. If you assume another origin, that may give you something, right? So since calculation will be easy, I make this type of origin, right? If you make E as origin, the value will be, the system will generate a different thing, right? Now, at the end, you have to use the formula. Now you apply the formula and get the answer. Very easy, right? Okay. Now, so the deflection at point E in this case will be, now look. So write the formula. Summation M by EI, right? So this will be dx. Okay, integration of 0 to 2, first is your 20x into x is 20x square by EI is constant here, the dx. So I consider A as origin now first, plus 0 to 2 to 4, this is 40x dx by EI. Now plus so CD section limit, I take this as origin, so what will be happening? 0 to 4, this will be 40 plus 10x minus 5x square times 4 minus x by 2 dx. Okay, so if you take this, the value will be coming out to be 720 by EI. That will be the value of E. Since it come as positive, your deflection is like this, right? So this is the way you have to do calculations. Since for DE section and EF section, since there is the 0, the involvement of 0 makes the total value as 0. Since the product of these two is something 0, right? Again, if you do not like this, you can do another thing, is that you use the origin as A, you use, or you can use this one, plus you can use this one, or you can use this one, right? So that will again give the value will be the, ultimately the value will be coming out to be same thing, right? Okay, so if you use the deflection by using another thing, the what will be the value coming out to be, right? So the value limit 0 to 2, this is 20x square by EI times dx, plus this is BC, and you consider B as origin, you take this, it will be 0 to 2, this is 40 times x plus 2 dx, plus if you take the limit this one, D as a origin, so you have to take 0 to 4, 30x minus 5x square times 2 plus x by 2 dx. Since this will be giving 0, this will be giving 0, no any effect. If you solve this, again it will be 720 by EI in this direction. So this is the way you can solve this type of problem of theory of structure first for the university level examinations. So thank you so much. Have a great day. Bye bye. Stay tuned to our channel, DCB.